Good afternoon, grade 8s. We are back with question 3.2, and it reads as follows. Determine whether the following triangle is a right-angled triangle. If so, also state which angle is equal to 90 degrees. So bepaal of die volgende driehoek reghoekig is of nie. Indien wel, sê ook watter hoek gelyk is aan 90 grade. Now, I've seen some approaches to this type of calculation from some learners, and again I'm going to focus on the one that I teach, which should or could be seen as the generic way of doing it, or the standard way, or the universal way, whatever you want to call it. Just from my perspective, the best method that most learners can adapt to, and it's also the method that you would find in most textbooks as well. So when you are trying to determine whether a triangle is right angled or not, the first thing I want to say is you cannot look at this diagram and say, well, this doesn't look like a right angled triangle, so it can't be. Or you can't say, well, it kind of looks like one of these angles on 90 degrees, so it must be. In geometry, we cannot go according to looks. We need to, of course, prove or show or be given information in order to prove something. So in this case, we of course need to go prove that this is right angle triangle, and we need to use our knowledge of Pythagoras, of course, to do that. And this is of course making use of the converse of the theorem of Pythagoras. So the converse of the Pythagorean theorem, as it's also called. Starting off, we of course, assuming that this is a right angle triangle, or if it had to be one, we could of course identify this side AM as our hypotenuse. Why? Because it is the longer of the three sides. So 5,3 of die sy AM. Die sy AM is die langste van die drie sye, so dit sou dan die skynsy wees as dit 'n reghoekige driehoek is, wat beteken dat hoek C dan die 90 grade hoek sou wees as dit 'n reghoekige driehoek gaan wees of sou wees. Ons weet nog nie of dit is nie, ons moet dit bewys. So ons kan nie aanneem en die stelling van Pythagoras gebruik om dit te bewys nie. Ons moet soort van bewys dat die stelling waar is. So hoe bereken ons dit? Well, so how do we prove this? We basically make use of the Pythagorean theorem, or the theorem of Pythagoras, and test if it works in this particular triangle. So identifying which side would be the hypotenuse, in that case here AM, we can say, well, let's see what is AM squared, right? Because the hypotenuse squared is equal to the sum of the squares of the other two sides. So if we can prove that AM squared is equal to AC squared plus CM squared, then we have proven that this is a right angle triangle, because Pythagoras works in there. So we will then proceed to say, okay, let's go see what is AM squared. Now, AM squared is equal to 5,3 squared. And if I find out what is 5,3 squared, that is equal to 28,09. So AM squared is equal to 28,09. AM to die mag 2 is gelyk aan 28,09. And then my next step would be to find out, well, let's see what is the value of AC squared plus CM squared. In other words, what is the value of AC squared and CM squared, because those would be the other two sides of the right angle triangle, if it is a right angle triangle. So let's go calculate what that is. So AM squared, of course, AC squared would be 2,8 squared, plus CM would be 4,5 squared. Notice I did not write Pythagoras anywhere yet as my reason, because I am not using the theorem yet. I'm trying to prove that the theorem works in this particular triangle. So 2,8 to the power of 2 is equal to 7,84, and 4,5 squared is equal to 20. comma 25. Adding this together, I have 28,09. So dit sê dan vir my dat AC to die mag 2 plus CM to die mag 2 is gelyk aan 28,09. Maar ons sien dan, okay, but AM to die mag 2 is ook 28,09. AC to die mag 2 plus CM to die mag 2 is ook 28,09. So that means I can now put AM squared and AC squared plus CM squared, they are equal. They are the same because they give us the same answer of 28,09. So I can then say, therefore, AM squared is equal to AC squared plus CM squared. And now I can say Pythagoras. So in that same line, I will use the reason Pythagoras because I have now proven it. So the statement I made here, the equation that I've constructed here is the equation of Pythagoras. It is proving the theorem of Pythagoras for this particular triangle. And I'm then going to follow up by saying, well, because that's true, it then means that triangle ACM, driehoek ACM is a right angled triangle. And this is the part that you sometimes forget. You need to indicate, as they've asked us here. They said, if so, also state which angle is equal to 90. So we said that if this had to be a right angle triangle with the hypotenuse being the longest side over here, then of course the 90-degree angle would be angle C. So we have proven that this is right angled, and we can say then therefore ACM is a right angle triangle with angle C equal to 90 degrees. So natuurlik in Afrikaans kan ons net sê this is as driehoek ACM. I'll just write the bottom part here, 'n reghoekige driehoek met hoek C gelyk aan 90 grade. And that is then the end of our proof. We have shown that, or we have determined that the triangle ACM is a right angle triangle, and we have also stated which angle is equal to 90 degrees, so we have answered the question in full.